Hi, welcome to my video on the area of a parallelogram and a rhombus. Area of a parallelogram. A parallelogram has like this shape, which is opposite sides are parallel to each other and the opposite sides are equal. But to derive the formula, let's work on the rectangle. We know that a rectangle has 4 right angles and it has a length and a width. So the area of a rectangle we know is length times width. But let's derive the area of a parallelogram. If you take a point on the AB and draw a line from this point E down to D, we create a triangle. If you take a scissors and cut off this triangle right here, cut this triangle off, and take it, and now just indicates that we cut the triangle off and we move the triangle over to here. So cut it off of here and move it over on this side of BC. So now we have that E, this figure, is the shape of a parallelogram, which says opposite sides are parallel, and we know that the opposite sides are equal. But what happens is that the AD, which is the width of the parallelogram, that was the width right there, that width of the rectangle now becomes the height of the parallelogram, and the length of the rectangle becomes the base of the parallelogram, because the formula for a parallelogram is base times height. So the length is replaced by the base and the width is replaced by the height. So for any parallelogram, the area is base times height. Very similar to the rectangle, of length times width. Only in a rectangle we got right angles. So parallelogram area is base times height. So let's work out some examples. A, we have a parallelogram, opposite sides equal, opposite sides parallel. And so we have a base of 5 and we have a height, and the height is drawn from the perpendicular distance between the two parallel lines. So there's the height, perpendicular distance between these two parallel lines. So the height is 2. So the area is base times height of a parallelogram. So it's 5 times 2, and we get 10, and it's areas, so it's meters squared. B, we have a base, which is the bottom part, is 8.4. And again, we can either have the height out here from, this is the perpendicular distance between these two parallel lines, or we can have the height in here. Don't make any difference. We could have the height right here if we want, as long as it's the perpendicular distance between the two parallel lines. So the height is 3. So the area is base times height. The base is 8.4. The height is 3. And when we multiply it, we get 25.2. And the unit is feet, so it's square feet. 8.4 times 3 with a calculator gives you 25.2. And it's square feet. C, we have a base, which is the bottom of 4 2/3. We have a height, which is the perpendicular distance between the two parallel lines, is 6. So the area is base times height. The base is 4 2/3. The height is 6. And when we multiply, we change the mixed numeral to an improper fraction. 4 times 3 plus 2 is 14/3. And we cancel that because 6 is over 1. 3 into 3 is once. 3 into 6 is 2. So it's 2 times 14 is 28. And we have centimeters, so we have centimeters squared. Practice means you pause the video, work out the answers, and play it back to see if you're right. The area of a parallelogram, notice this is the symbol I use, parallelogram. It's a shortcut for writing out parallelogram. Area of parallelogram is base times height. The base is 11. The height is the perpendicular distance of 5. Remember, that's 11 up there. This is also 11 down here. And the height could be, I repeat, the height could be here, or the height could be anywhere, long as it's the perpendicular distance between the parallel lines. So, and that's 55, and it's inches, so it's inches squared. Again, area is 2 dimensions, so square. Number 2, we have a parallelogram again, so the area is base times height. The base is on the bottom, 3.5, and the height is the perpendicular distance of 2.4. And we can change the half to 3.5. And we multiply those with a calculator, we'll get 8.4. And it's millimeters squared. What you have to be careful to make sure both units are the same. You have to have them in the same units to multiply. Don't forget, watch out, same units for each one. Length, width, base, and height, etc., etc. And practice, continue. Pause the video. A parallelogram has a height of 16 and a base which is the square root of the height. So we know that the parallelogram has a height of 16, right? The base is the square root of the height. So the base, b, is the square root of the height. So that means if the base is the square root of the height and the height is 16, so the base is the square root of 16, square root of 16 is 4. So we have a base and a height. So a parallelogram is base times height, and the base is 4, and the height is 16, and that gives me 64, and the units is meters, so it's meters squared. Let's continue on to find the area of a rhombus, because a parallelogram and a rhombus areas are found the same. A rhombus is a parallelogram. So this is a parallelogram. Remember, the parallel sides, opposite sides are parallel, opposite sides are equal. And this is a base, and this is your height of your parallelogram. So a rhombus is the same as a parallelogram, because a rhombus is a parallelogram. The only difference is that a rhombus got all sides equal. So if that's a B, then that's a B, and that's a B, and that's a B, but that's still your height. So the area of a rhombus is the same as base times height, because a rhombus is a parallelogram. Only thing, in a rhombus, all sides are equal. So the area of a rhombus is base times height. So find the area of each. Notice this is a rhombus, because all sides are equal. So it's a base times height. The base is 7. The height is the perpendicular distance between the parallel lines, because these lines are parallel to each other. Opposite sides are parallel. And so the height is 4, so it gives us 28. And is meters, so it's meters squared. And we have another rhombus. All 4 sides are equal. We have a base of 12 here. Remember, all these sides are 12, because it's a rhombus. And the height is the perpendicular distance between the 2 parallel lines. So there's the height of 10.5. So the area is base times height. The base is 12, and the height is 10.6. We multiply that out, we get 127.2. Use your calculator. And we got feet, so we got square feet. And number 3, a rhombus has a perimeter of 32. If the height is the side less 3, find the area. Well, we got a rhombus with a perimeter of 32. Remember, the formula for a rhombus is 4s, because all 4 sides are the same. So 32 equals 4s. We divide by 4. We get s equals 8. So that's 8 centimeters. It says the height is the side less 3. So the height is h, is the side, which is the side less 3. So that means the height, S is the side. So the side is 8. 8 less 3, so that means the height is 5. And we want to find the area. Area is base times height. The base is 8. The height is 5. So 5/8 are 40, and the centimeters, so it's centimeters squared. Remember, this is 5 centimeters, and that's 8 centimeters. So the area, just working the problems a little bit different to make you think, not just a straightforward problem. Because in math, thinking develops your ability to do the math. Always be thinking. Let's continue. Practice. Pause the video and see if you can work this out. Extra thinking here. Extra thinking. Number 4. For any rhombus, what height would the area and the perimeter have the same numerical value? For a rhombus, so here's a rhombus which got 4 sides equal. And we got S and an S and an S and an S. And we have a height. It's the perpendicular distance between the two parallel lines. So what we're saying is that for any rhombus, no matter what the sides are, what height would the area and the perimeter have the same numerical value, even though area is square and perimeter is just a straight unit. We're talking about the numerical values. With the area, well, the area of a rhombus is base times height. And the perimeter of a rhombus is P equals 4S. So let's look at, in a rhombus, it's the base is S. B is S. The perimeter is 4S. So if the area is SH and the perimeter is 4S, that means we can make, if the area is equal to the perimeter, then SH is equal to 4S. And if we divide both sides by S, the height becomes 4. So when a rhombus has a height of 4, its area will be the same numerical value as its perimeter. And just to illustrate that, let's have a go at this. Let's make this height 4. And let's put any, whatever we want. Let's make this a 6, a 6, a 6, and a 6. So here's a rhombus with all sides equal with a height of 4. Let's work out its area. Its area is base times height. So that's base is 6, height of 4. So that's a 24 square units. And the perimeter is 4S. So that's 4 times 6. So you can see that both of them are both 24. Now, this is square units, and this is, so if this was centimeters, yes, this would be 24 square centimeters because it's area, and this would only be 24 centimeters. So they're not related. We're only talking about the numerical values. Notice 24 square centimeters is not the same as 24 centimeters, but the numerical values are both 24s. So I thought I might give them extra problem. Always help in your thinking. Develop the thinking. If you like my video, click the like button. Click the subscribe button if you're not a subscriber, and click the notification bell. Write a comment if you're a subscriber on this video, and visit my math website at www.mathfullyexplained.com and get information on me, my videos, and the content that's going to be on my YouTube channels. Thank you very much. Bye-bye.